Today I want to look at friction. And friction, as we've maybe seen in further miles, is a force that opposes motion. You'll know that when you push something along your desk, for example, it stops. If you don't keep pushing it, it stops. And that's because there's a frictional force that opposes the motion and causes it to slow down and stop. So friction is between two surfaces and it always opposes the motion. Friction is also proportional to the normal reaction. We've seen that when a body sits on a desk or sits on a table, it has a weight acting down through the table, but the table also provides a normal reaction upwards. And we've calculated that before, but we haven't used that before in calculations. But the normal reaction is an important force because it's used to help find the value of friction. And friction F is equal to mu R. And mu, this value mu, is what we call the coefficient of friction. It's a value that's given that depends on the two surfaces in contact. So say something that's in mud will have a higher coefficient of friction. Mud and brick will have a much higher coefficient of friction between them than, say, ice and steel. This bit at the bottom, very, very important. At the moment a body is about to slide, the frictional force is at its maximum value. And we call this limiting friction or F max. So the maximum value of friction happens when something is about to slide or when it is actually sliding. Up to that point, friction just causes something just to stay still. It will not move. But once we overpower the limiting friction or F max, then a body will start to move. So here we've got a wee example. A block of mass, 5 kilograms, rests on a rough horizontal plane. So there's the first thing, very, very important. This value is rough. That tells us it's not smooth and that we have to involve friction. The coefficient between the block and the plane is 0.6. So if you want, we can write somewhere mu is 0.6. Calculate the frictional force acting on the block when a horizontal force P is applied and the magnitude of P is such and such. Okay, well the first thing I'm going to do is just imagine this situation. We've got the block of 5 kilograms and so I have acting down my weight 5g and I have this normal reaction acting up and we're given this value P, some force P. But if P wants to move things to the right, then my frictional force, let's call it FR for the minute, is acting to the left. It's going to act against that. And what I want to do, first of all, is find, what is the maximum value of friction? So F max is equal to mu times R, which in this case is 0.6 times whatever R is. Now, if we look vertically at this, you can see that vertically, it's not moving up or down. So R must equal 5g. And so R equals 5g, 5 times 9.8 in this case. And so the maximum value of friction is 29.4 newtons. So that's the maximum value that friction can be. Now, in part A, the value of P here is 12 newtons. P is going with 12 newtons. That means P is not big enough, a big enough force to override any maximum friction. So the value of P is 12, but friction will not overpower this value P. It can't make the body go to the left just because the maximum value is 29.4. So in this case, our value of friction, frictional force, is just going to match P. It's going to be 12 newtons. And likewise for part B, for 28 newtons, if P is 28 newtons, it still will not override the maximum value of friction. It will not get past 29.4. And so friction will just go up to, but not surpass this force, so it's going to be 28 newtons. However, for the last value, what we've got, and let's just redraw it quickly. So we've got R, we've got our 5G. This time we have a force going is 36 newtons. And our frictional force, we know, is up to 29.4 newtons. So I can put 29.4 newtons. It will be acting at its maximum value here. And what's going to happen is our force 36 is going to overpower the 29.4 newtons, and this body is going to accelerate to the right. And so using Newton's second law, F equals ma, I can see that 36 minus 29.4 is equal to the mass, which is 5 times the acceleration. And the acceleration then is 6.6 divided by 5, which is 1.32. This question is much easier, as all we're asked to do is find the maximum frictional force. Now in this case, again, we're told it's a rough horizontal surface, so therefore friction is involved. And again, just a quick diagram. Here's our surface. A block of 2 kilograms is sitting on that. And on that I have the weight acting down, which is going to be 2g. And I have a normal reaction acting up. And our maximum value of friction then, F max, is mu times R. So the coefficient of friction is 0.7. The normal reaction we can find if we resolve vertically, then R equals 2g, which is 19.6. So this is 0.7 times 19.6, which is 13.72 newtons. And that's our maximum value of friction, or the limiting friction. Again, this example, we have a rough horizontal plane, so I know immediately that friction is involved. And we're told that mu is 0.4. So let's draw the scenario again. So here's our block on horizontal ground. It's 5 kilograms. And I have the weight of that, 5g acting down. I have normal reaction acting up. And we have a horizontal force here of P, and this is very, very important. The block is about to slide. If it's about to slide, we're using maximum value of friction, or the limiting value of friction. So it's going to oppose motion, and I'm just going to write mu r, because I know that F max is mu r. So let's find out the different bits and pieces here. Vertically, it's nice and easy to see that R equals 5g, which is 49 newtons. Horizontally, albeit it's about to slide, it's not at the moment, and so actually this is sitting in equilibrium, it's not moving. So we can see left and right, P equals mu r. Mu is 0.4, we've worked out, that R is 49, and so when we do 0.4 times 49, we get 19.6 newtons, and so the force P is 19.6. If the force were any greater than 19.6, then the body will start moving with an acceleration over to the right here. This example, we have then a force that is not horizontal. But again, we're going to start with a diagram. We have a 4 kilogram box, and the weight of that box is acting straight down, so 4g. We have a normal reaction acting up. But this time we have a rope that's inclined at 40 degrees above the horizontal. So 40 degrees here. And in that rope, the tension is 20 newtons, so that 20 newtons is acting that way. Again, the box is on the point of moving. So that means we're talking about limiting friction. We're using F max. And the friction will oppose motion. So I'm going to put here mu r. The friction is going to oppose moving to the right. Now here we just need to be a little bit careful. We're going to go about it in the same way, but we do need to be a little bit careful because when we resolve, we have r going up, but like this tension and string will also have an upwards or a vertical component. So we just need to take that into account. When we look then vertically, we can see that r plus 20 sine 40 is equal to 4g. And so we can change that around to find that r is 26.344 newtons. Horizontally then, again there's on the point of moving, but it's not quite moving yet. We can see then the forces to the right is 20 cos 40 will equal the force to the left, which in this case is the maximum frictional force. So mu r, or 20 cos 40 is equal to mu times 26.344. And so we can change that around to find mu is equal to 0.582. And that coefficient of friction is just a coefficient, it's a number, it doesn't have any units with it. Finally, for the moment, this example here, you can see here we find the value of the coefficient of friction. So we're talking about a rough plane. But here also you'll see we have an acceleration. This body is moving to the left. And so all I'm going to do is add on to this diagram. This is 20g, the weight. And then this is our normal reaction here. And if our value of is going to the left, our friction, mu r, will go to the right. So the body's moving left, so friction will oppose that motion and go to the right. So let's put all this in now. Again, same sort of thing. Let's resolve vertically to find r. R is 20g, which is 196 newtons. Horizontally, because it's moving with an acceleration, we can use Newton's second law. So F equals ma. And let's fill in. Overall, it's going to the left, so 100 newtons. 100 newtons. Take away what's going to the right, take away 20, take away mu r is equal to the mass, which is 20, times the acceleration, which is 1. And so this is 80 minus 196 mu is equal to 20, or 60 equals 196 mu, and so mu is equal to 0.306.